circumference to diameter for any circle, no matter how big or small.
Mm-hmm.
And so the diameter, we could call this, C over 2R, right? And that gives us the standard formula for the circumference of a circle, 2 pi r. It's an equivalent statement. So that's where that formula comes from, right? So we know that the circumference to the radius is going to be 2 pi. And let's see, what do I want to say here? Let's talk about this ratio. The circumference to 300, so the degree measure of the circumference is 360 degrees, right? The radian measure of the circumference is 2 pi, right? So if I write that, of the unit circle, right? So if I substitute 2 pi r for the circumference, I get pi r over 180. Now that's in a circle of radius 1, sorry, the radius, general radius, but so if we take r equal to 1, then we get pi over 180 is this ratio of circumference to degree measure of circumference. That's that ratio, right? And in some sense, this is equal to 1, right? So if you're thinking of the circumference measured in degrees, then, well, the circumference of a circle is 360 degrees, and this would be the number 1 in some sense, right? This is a conversion factor in that sense, that we can use this to convert from degrees to radians. So this is the conversion factor from degrees to radians. What if you want to go the other way? Yeah, so 180 over pi is also equal to 1, right? The reciprocal of 1, and that's the conversion factor from radians to degrees, and the abbreviation of degrees there, right? So if we want to say what is 1 and what's the degree measure of 1, we would say, well, 180 degrees divided by pi is the degree measure of 1 radian, right? And how do you write that? Well, you can do the long division here, right? What is pi? As a numerical approximation, about 3.1416. So if we were to use that, pi over 3.1416, so 1 is approximately equal to that. And what do we get? Well, we have to sorry, let's put the 180 degrees up here, okay? So 31416, we go into this number, which we then multiply by 10,000. 1, 2, 3, 4. All right, and how many times does this go in? Well, 5, and we get 3, 5, 8, and carry the 2, 7, 15, and subtract, you get 2, 9, 2, right? And so then this would be a 7, and 7 times this is going to be 42, carry the 4, 11, carry the 1, 29, carry the 2, 9, and 21. Okay, so then what's left over? Well, 8, this is arithmetic, right? 9 minus 1 is 8, 11 minus 9 is 2, 18 minus 9 is 9. So then we're into the tenths place, right? Do we want to convert to tenths, or just take that as the remainder? Well, let's just use a calculator so we get it more precisely done, right? So what would a calculator have us compute here? We would have 180 divided by pi. It's going to be approximately 0.29 there, right? 0.295, so I guess closer to 0.30 than anything else. So we could write a 0.30 there. That would be to the nearest hundredth of a degree. But we want to convert this to minutes, right? So how many minutes? 30 hundredths. So 30 hundredths of a degree is going to be multiplied by 60 seconds per 1 degree, right? So you're going to have 1800 over 100, or simply 18, and that'll be in now minutes, right? So this would be 18 minutes, and so we can say that.
I'm an artist.
Yeah. 57. And 18 minutes, right? Or in our sexagesimal notation, that would be 57 semicolon 18. Or in Ptolemy's table, it's a little bit different, right? So shall we go look at Ptolemy's table? Where is that? Here? Yeah. So if you have an arc of 60 degrees, the chord measure of that arc is 57 degrees in 18 minutes. Notice it's not a semicolon here. It's just, a variation on how you write these things. So just roll with it.
Does it matter if it's a comma or
In this table, the notation has been changed from semicolon to comma, and so these are all measured in degrees and minutes, separated by a comma rather than by a semicolon, for whatever reason, right? It's a reconstruction of the table, and why they settled on this particular reconstruction, I don't know. If you take our diagram and bisect one of these angles, so can I do that? Can I hide these things? So I'm just going to say, don't show me that. Just don't show me the circle.